Hey guys, so I just wanted to show you the new application I'm working on at the moment. So it's going to be an educational tool for people who learn Michelson. The goal of the tool is to be able to use instructions and see how they modify the stack in with some visual feedback and visual elements. So for these demonstrations, we're going to build a very simple smart contract. You can see that the application is divided in two parts. On the left side is where you're going to enter all the instructions and information about the contract that you're building. And on the right side, you're going to have a representation of the stack. So let's start. So for the parameter, we can use int6. We can have a nat9 in the storage. Then you just click on init contract, and it's going to start building the code for the contract here. And it brought down on the stack the pair containing the parameter and the storage. Now we can start writing instructions to manipulate the stack. Let's start with dub. So when you're going to write instructions, you will see that the application is going to suggest you instructions. For example, here we typed du, but it suggests dub. At the same time, you will also get error messages about what you're writing if it's not right. For example, here du is an instruction that doesn't exist. Let's write dub. So when the instruction you typed is correct, you will get a green bar here, no error. You also get an explanation of what the instruction does. And there's also visual feedback for some instructions about the block, the element in the stack that's going to be affected by the instruction. Let's just validate it. And now we have two elements in the stack. At the same time, you will see that the application builds the contract with the instructions that you enter. Now we would like to access the left field of the pair. You can write car, and here you can see that the application is saying that we're going to get an int6 out of that instruction. So let's continue. Now we have the int6 on top of the stack. Let's swap the two values so we can work with the second pair. Now we would like to access the right side. Okay, now we have these two values, these two numeric values on top of the stack, and we would like to add them together. So we can use add, and you see that the application is going to give you the expected result of the addition of the two values. So we can go ahead. We have int15. If you remember, the storage is a nat value, so we would like to convert that into a nat value, and we can use abs. As usual, you also get an explanation of what the instruction does. Let's go ahead with abs. Now we have nat15 on top of the stack, and it's time to finish the execution of the contract. So we can push an empty list of operation. So you can see that if you just type nil, the application is going to complain that it expects nil expects one argument, and you're providing no argument. If you provide an argument that doesn't exist, it's also going to tell you that it doesn't recognize that type. But if you write the right type, then everything is fine. We can push the list on top of the stack. Now we can pair it. As you can see, there's visual feedback, about the two elements that are going to be affected by the pair instruction. And that's it. The smart contract is complete. In addition of building smart contracts like that, you can also use the application to just write instructions and see what they do. So, for example, we're going to start writing drop, and you will see that we have an error message saying that the drop instruction doesn't work with an empty stack. So the application is based on a virtual stack that's going to be updated after each instruction. So the application knows how the stack looks like at any time, and it's going to give you feedback about if the instruction you're trying to use is compatible with the state of the stack. So here it's not. So for example, we can use balance, not balance. So balance is going to bring down the current balance of the smart contract. So here it's just going to be a random number. After that, we can add a list of microtests, and we would like to put the balance inside the list, so we can swap the two elements and use the cons instruction to put the balance inside the list. Now you see that the balance is inside the list, and you can see there is one element in the list. We can also check that with the size instruction. And before you validate the instruction, you're going to get some feedback about the size of the list. Okay, so there's only one element in the list. But let's try something else. Let's try to put some numeric values on the stack. You can compare those values. You see you're going to get feedback about the result of comparing not 9 and not 6. It's going to be 1 because 9 is greater than 6. We can validate that, and then we can use eq that checks that the top of the stack equals 0. So it's not the case, so it's going to return Boolean with the value false. Like so. Now you can also work with the strings. So let's try this one. String Tezos. And then you can try concat. And you see the two strings are not in the right order. So first we have to swap them. And then concat. You're going to see, before you validate the instruction, you're going to see the result that you can expect from the instruction. Like that. And you can also use size on strings. And the size is 11. You also have access to other instructions like now. It's going to push the current timestamp on the stack. And we can use drop to remove one of the elements of the stack. So if you just use drop, you will see that the first element starts to vibrate, but if you want to drop another element, it's going to give you a visual feedback of which element is going to be dropped from the stack. So drop 3, drop 4, drop 4. And if you try to drop an element that doesn't exist, then it's going to tell you that the stack is not deep enough. You're trying to access an element that doesn't exist. So let's drop, for example, 3. And that's it. So now at the moment I'm working on supporting conditionals. Let's have an example. If I type if sum, we're going to push a string, yes. Otherwise, we're going to use fail with. And here the application tells you that it was expecting an optional value on top of the stack, and there's a timestamp. So let's push an optional value and let's make it none, so we can see the contract fail. Now if I use this one, you can see that there's no error anymore, and this element is going to be affected. And the documentation, I mean, the app knows that it's going to fail, so it gives you the documentation for the fail with instruction. Now let's validate it. And that's it. The contract failed. So that was the demonstration for this app. So you can see that a lot of things works already, but only simple instructions. And I'm going to add very soon more complex instructions. And hopefully it's going to help a lot of people who are learning Michelson or who didn't want to learn Michelson because it's a little bit difficult to learn it by yourself because the documentation is a little bit complex. And this kind of tool would be really great to make Michelson, to bring more people to learn this language and understand better what's happening in a smart contract. So thank you for watching. See you later. Bye.